So a combination is not that difficult. It's actually kind of very simple to like perform calculations in your calculator. Direct answers also you can get and write off. And once you are done with this module, so fourth module also much parts are like repeated. So it will be easy for us to solve those models with the help of these models. So you're selecting a set of R objects from a set of N objects such that N is greater than equal to R. Obviously, you have 0 to N in that some portion you're taking that is R. Okay, without regards to order, without the regard of order to order. So here we are not caring about the order. It is called combination of R objects. See, from wherever we'll take. I won't take exactly from 2 to 7. I will take like from here 1 I'll take, from here I'll take 1, I'll take 7, then I'll take 13, then I'll take 19, like that, so on. Okay, so the total number of combination of R different objects that can be selected from n different objects is denoted by C of n comma R. Their permutation arrangement was denoted by P of n comma. Here combination is denoted by C of n comma or NCR. NCR is in your calculator. Shift and division button. You will get your NCR. Okay, and is given by NCR is equals to n factorial divided by n minus R factorial into again R factorial. There only we had n factorial divided by n minus R factorial. Here only extra thing is this again will multiply with R factorial. That's it. Okay. Now let us see the problem. How many committees of 5 members with one chairperson can be selected from 12 persons? Okay. Committees of 5 members are there with one chairperson. So among that 5, one is chairperson. With one chairperson can be selected from 12 persons. So one chairperson out of 12 persons can be selected in 12 ways. The remaining 4 members out of 11 persons can be selected in. Okay, so among 5 members, committees of 5 members are there. In with one chairperson can be selected from 12 persons. So for 12, from 12 person, I have to select one chairperson, and one that chairperson can be selected only from this committee members. Okay, so one members can be selected from the among 12 members. So I have selected one. So remaining is 11. One chairperson I took off. Okay, 1 plus 11 gives me 12, right? So this one chairperson I took off. Remaining is 11. In this 11, remaining 4 members, how I will select? 4 committee members. Okay, among 12 members, 5 should be committee members, and among that 5 committee members, 1 should be the chairperson. So now one committee and one chairperson done. So remaining 4 I have to do. How I can select that? It is 11 C4 ways. That's it. Just in your calculator, if you type 11 into just first type 11, then shift division, then type 4. Okay. So, okay, on it write 11, press shift division, C will appear in your calculator, scientific calculator, then 4. So it will give you exactly the answer. Okay, required number of committees is equals to, therefore required number, so this is nothing but 330. 330. Okay, then required number of committees is equals to 12 into 11 C4, that is equals to 330 into 12, that will be 3960. Simple, right? Much more is not there. Okay, one chairperson out of 12 can be selected in 12 ways. Then therefore 4 members out of 11 persons can be selected in 11 C4 ways. 4 members have selected, but committees should be there, right? So total required number of committees will be total 12 committees. A certain question paper contains 3 parts ABC with 4 questions on part A. Part A is having 4 questions, part B is having 5 questions, part C is having 6 questions. Okay, it is required to answer 7 questions, selecting at least 2 from each part. From each thing, 2 I have to select. Okay, I can select 2, then minimum 2 should be selected. Then 7 questions I have to write totally, at least 2 from each one. So total 7 questions, at least 2. So from each 2 I have to write. In one thing I'll write extra. Okay. In how many different ways can a student select his questions for answering? See, number of questions it contains 4, 5, 6. Number of questions chosen, case 1, case 2, case 3. So see here what I'm doing. First, all should be 2, right? All will be 2, but 1 will be more. 7, total should be 7, right? Total number of things should be 7. So I'll take case 3, part C, 1 extra. In this, I'll take part B, 1 extra. In this part A, I'll take 1 extra. Okay, here part A I'm taking extra, here part B I'm taking extra, and here part C I'm taking extra. Number of ways of selection. So see here, 4C2 here 4 into C2, 5 C2, 6 C3. Okay, same way. 4 C2, 5 C3, 6 C3, 4 6 C3. Then 4 C3, 5 C2, 6 C2. That's it. That is your S1, S2, S3. You just have to add this thing. Okay, you will get particular answers, and then that is your final answer. Calculation you have to do, man. You can't just see the video and do. See, you have ample of time, right? If you're seeing at the end, then you have to try like somehow by adding up or something like that. But if not you have time, then you have to solve. Okay, then find the number of committees of 5 that can be selected from 7 men and 5 women if the committee is to consist of at least one man and at least one woman. So see, if they had not given this condition, then what I could do, I could have taken all as men or I could have taken all as women. But here only one man should be there and one woman at least. So two, at least one man and at least one woman. So now see here, 7 men are there, 5 women are there. Okay, 7 men, 5 women. In that one will be there. So remaining are 6 women and 6 men and 4 women. Now see here, if I am taking one man and one woman, so how many seats are available? So among the remaining 6 places, one will reduce this. Okay, why? Because instead of 6, one woman will take. And this is just for your reference. Okay, now see here, 5 committees. In that, 1 man, 2 men, 3 men, 4 men. Okay, these are erased. I just try to explain in general, which is not required, was not required. Now see here, draw. So total 5. I have to write in such a way that, okay, this plus this should be 5 itself, and there should be no zero value in both the places. Okay, if I am considering one man, okay, 7 into C1, so 7 C1, 7 C2, 7 C3, 7 C4. Same way, let me erase this plus symbol here. 5C into 4 into 3, 5C4, 5C2, 5C2, 1. This thing will be multiplied. Understood, right? Just from this try like this. How to get these values? Understand from this. Keep get the values. Okay. Then you have to add all these 4 values. You will get this value. Understood? Simple, right? 5 members are there. Committee can be made only from 5 members. So in each committee, 5 should be there. And among that 5 committee, each should have at least one man and at least one woman. So we know that the number of men and women there, 2 places already taken. That is one man and one woman. So remaining can either all be men can and either all be women, like that. One man, all women, then one woman, all men, then 2 men, 3 men, 4 men. I cannot take 5 men. Why? Because it will become one should it will not satisfy the condition, like that. Okay, like that you have to take. And then a woman has 11 close relatives. She wishes to invite 5 of them to dinner. In how many ways she can invite them in the following situations? See, she is having total what 11, and she has wishes to invite only 5 of them. Out of 11, only 5 she wants to invite. So in 3 ways they are saying how she can invite. If first condition, there is no restrictions on the choice. Okay, see now, since there is no restriction on the choice, 5 out of 11 can be invited in 11 C5 ways. See, 5 out of 11. So 11 C5, whatever the answer you will write off. Second, two particular persons will not attend separately. So we have two particular persons who will not attend separately. So in this we'll have 2 ways. One, both are invited and both are not invited. So since they are okay, if one is not invited, obviously B is also not invited. Or else if this is invited, both are invited. Okay, if one is not invited, both are not invited. So we have to find 2 cases. So if both A and B are invited, then number of ways the selection is, okay, 9C3. Why we have taken 9C3? Okay, we have removed 2 from this and 2 from this, because they won't be attending separately, right? They will be attending together. So we are saying both A and B are invited. So already they are invited. So remaining positions from remaining persons, then see, total 11 persons were there, and total 5 persons to be invited. In that already we invited 2. So remaining is 3% should be invited. In this already those two who are invited are been taken. So the remaining is 9. So remaining from 9 persons I have to just invite 3. So 3 out of 9. So 9 C3 is equals to 84 ways. If both are not invited. Now if both are not invited. So now see both are not invited. So among 11 I'm not inviting those two persons. So 9 persons are remaining, but still 5 persons should be invited. So among 9, 5 out of 9. I'll add this. So it can be either this or this. Then third following question, two particular persons will not attend together. So that together they won't attend. So the following cases arises. If A is invited and B is not invited, then the number of ways the selection can be. So A is invited but B is not invited. Now see, if A is there, it won't and B is there. Okay, if suppose A is there, B won't attend. If B is there, A won't attend. Now what I have to do? I have to remove here two persons also. The number of ways selection is 9C4 is equals to 1. See why 9 means both the if I am saying if okay 11 persons are there, I am inviting A. Because of inviting A, 10 persons are remaining. But since I have invited A, then 9 won't come. 9 sorry, B will say of she won't come. So obviously this 10 persons will become 9 persons. And then now we want to still only one person is invited, right? Still 4 persons are remaining. So 4 out of 9. Okay, then if B is invited and A is not invited, same ulta will happen. 9C4 same way. Okay, like that you will write and do off. Then again thing is there, if both A and B are not invited. See here, if only A is invited, B is not invited. Here B is invited, A is not invited. Now here what I will do, both A and B are not invited. Among 11 person, I am not inviting A and B. So here this 11 will become 9. Still no one is invited. So here 5. So it will be 9C5. Okay, like that you will find. Now you can see this question. Okay, I'll explain this one question and then I can happily leave the rest for you to solve. From the number of arrangement of the letters of the word Tala has said something. This thing is important. Why? Because I have asked in question paper how many of these D arrangements have no adjacents A. So they won't have adjacent A. How many of these won't have adjacent adjacent? First, given word has 11 letters, in which there are 3 times A are there, 3 times A, 2 times L, S and E, and only 1 time T and H. T and H instead of okay H. So number of such arrangements is I am using that permutation formula 11 factorial divided by see they have not asked they have asked arrangement, so permutation will come. Hey, this is same, right? That masa honga like that. Why should I say? You know how to do this. Okay, and if A's are discarded, so if A's are discarded, so this they are saying that nothing should have adjacent of A. So before and after A should not be there. So I'll just remove A. So here this I'll just remove off. So remaining this will be the same. And here in 11 I'll remove 3 minus 3 I'll do. So there will be 11 minus 3 is nothing but 8. Okay, always we'll do here, but don't forget to subtract on the numerator also. Done. Find how many distinct 4 digits integers can one make from the digits 1. This is already done. Same way, a man has 15 close friends, of whom 6 are women. And in how many ways can he invite 3 or more male friends? Okay, simple, right? So I'll read the question again. A man has 15 close friends. Their woman has 12. Many is having more. Okay, in that 6 are women. Okay, almost half. And in how many ways he can invite 3 or more close friends of these friends to a party if he wants the same number of men, including himself, as women. Okay, how many men are there? That many women should be there. Okay, out of 15 friends, okay, 6 are women friends and therefore 9 are men. If 2 women are there, then 1 woman is equals to himself in all the cases plus himself in all the cases. Okay, so only 2 okay, if he is inviting 2 women, then he has to invite only 1 woman extra. Why? Because he is there in all the places. So here see plus 1 is there also here. Here also 1 is there, here also 1 is there, here also 1 is there, here also 1 is there. Including himself. If he remove himself among that his 9 close friends, how many he has to invite? Only one. Why? Because he has to balance this, right? Number of men and women. So here, if he is inviting two women, then here obviously has one woman. Same way, how many total women are there? 6. We have to just 6 C2, C3, C4 like that. And here 9 C 1, 2, 3, 4, 5. You have to multiply this. Similar question was there. Then you have to add all this. Okay. In how many ways? In how many bytes contain? Exactly 2 ones. Exactly 4 ones. Exactly 6 ones. At least 6 ones. You just see here. Okay. So they have say they have first one in or here they are asking this in combination. So two ones can be chosen in 8 C2 ways, and each of the remaining 6 locations are filled by 0 only. So what is saying first? Exactly two ones. So only two ones should be there. Okay. Okay. Exactly two ones should be 1, 2, 3, 4, 5, 6, 7, 8. So only 2 times 1 can occur. Okay. Exactly two ones should be there. So 2 plus should be 1, and remaining it shouldn't be 1. So 6 times zeros. Okay. The number of bytes containing exactly two ones is equals to 8C2 into 1 power 6. Why he see why 8C2? So here actually it is 8C8 according to all possible locations. But here only two positions we are considering one. So it will be 8C2 into remaining 1 to the power of 6. Same way, exactly 6 ones. Okay, so instead of 8 positions, now see here 6 places are 1, 1, 2, 3, 4, 5, 6. So it will be 8C6 into 1 to the power of 2. Okay, exactly 6 as I did. Then exactly 4 ones. So instead of so C4 ones, this was 8C6 into 1 power 2. Here 8C4. Okay, this here one A will reduce. Okay, 8C4. Very simple, right? Then at least 6 ones should be there. At least means minimum 6 should be there. Minimum 6 ones should be 1, 2, 3, 4, 6 ones should be there. Okay, it can be more also. So for at least 6 it will be 6 ones it is 8C6. 7 it is 7 ones. At least 6 means it should be either 6 or 7 or 8 ones should be there. That's what the minimum greater than or equal to 6. Total it is 8. So from 8 greater than or equal to 6 it is 6, 7, 8. So you have to find the combination for 6, 7, 8 and add these 3. 8C6, 8C7, 8C8. You will add this, you will get this answer. So prove the following. This thing just see once. I'm not gonna do it. It's very a lot of thing for me. Pause it, see, take a thing and done. So we have a binomial and multinomial condition. This I'll do in what to say different video. Okay.
Can I please ask you to subscribe? That's all we want, man. Just press subscribe.